So we're going to look at what we've studied so far in chapter 3 thus far. So far we've done 3 sections, and we've talked about logarithms, natural logs. We've talked about expanding or compressing logarithms based on their different rules. We've also talked about graphing, and we've talked about compound interest, okay? So the first one, evaluate 10 to the power of log, I guess that would be 10, of 11. Okay, now anytime that they don't have a number with log, that's a common log. That's log base 10. So anytime you just see log, it's really the same as log base 10. And that's helpful because log base 10 or common log is what's on our calculator. So if you look at this one right here, one of those rules of logarithms actually shows that the 10 and the log, because it's the same base, cancel out, and my answer is what's left. So for example, if we had another one that was like 5 to the log of 5 of 7, 5 and log 5 would cancel out, and our answer would be 7. Useful, right? Okay, so let's look at the next one. Now, in this one, we're asked to condense it, all right? Now, one of the rules we have of logarithms is anytime a number out front is really to the power of what's in there, right? And so this is really log of 2x plus y to the 1/4 power. And then when we have minus, that actually means division. So we're actually dividing it by 3x plus 2y. And so if we look at this, it actually looks really close to something that we have, and that would be d. The only difference is they wrote it in a 4th root versus a power of 1/4. Okay? Next one. It says write 3 to the power of -4 equals 181 in logarithmic form. So that means we're going to use our log, right? So the first thing I see is that my base is 3. So it's going to be log of base 3. And then we think of the loop rule, right? The loop rule says that if we had log base 3 of something right here, right? So what it's equal to is the -4. So we would put -4 here, and then it would be 1/81, right? So if we think about it as loop rule, 3 to the power of -1/4 is equal to 1/81. So this right here, I guess without your little arrow, okay, I'll rewrite this. 1/81 is equal to -4. So that's what it is in logarithmic form. Okay? All right. I'm actually going to get rid of all of this. Okay, number 4. It says to evaluate log of the square root of 5 to the x, or 125. Okay, so what I'm going to do anytime I ask to evaluate, I'm going to set it equal to x. And then what I'm going to do is I'm going to do the loop rule. So this is really square root of 5 to the x power equals 125. Now there's lots of different ways we could solve this out. But one of the easiest, in my opinion, is to change this square root of 5 to be 5 to the 1/2 to the x is equal to 125. Now, this is really the same as 5 to the 1/2 x is equal to, and I can rewrite 125 as a power of 5, right? And that would be 5 to the 3rd. Okay, so 5 times 5 times 5 is 125. And so notice I both have base 5. So I can then say that if the 5's go away, right, I really just have 1/2 x is equal to 3, which means x is equal to 6. So if you wanted to evaluate this right here, your answer would be 6. Okay? Now, number 5 asks us to expand this natural log. So we start by rewriting it as best we can. So the first one we have is 1 minus p. So it's going to be ln of 1 minus p times d. But we said that ln's of x, y is equal to ln of x plus ln of y. And ln's of y divided by z is really the same as ln of y minus ln of z. Okay? So if I use those rules to help me expand this guy, it would end up being this. It would be ln of 1 minus p, and then see how it's times d, we would add ln of d. Now it's divided by, so I'm going to do minus, and it would be ln of the 6th root of 2 plus 5r. Now I'm almost done, except for I have that sixth root. And so if I wrote that as 2 plus 5r to the 1/6, I have to bring my powers down. That's one of our rules. So our final answer is ln of 1 minus p plus ln of d minus 1/6. Let me move this real quick. Ln of 2 plus 5r. And we wouldn't have to change that 2 plus 5r any further. So that's our expanded version. Okay, so it went from something small and compact to something much bigger. Now, number 6 asks us to graph the function log base 2 of x plus 1. So for that, I would strongly suggest using Desmos. And so we would say log base 2 of x plus 1. Boom, there it is right there. Okay, we notice that it crosses at 0, 0. Normally, remember, it crosses at 0, 1 right here. But because we have the plus 1, it moves everything to the left 1 unit, right? So we know for sure that's how we graph it. And on the assignment, it'll be, or on your quiz, excuse me, it'll be like matching the graph, whatever, okay? Okay, number 7, evaluate, okay? Now, we're asked to evaluate this. So what I would do is remember the change of base formula, okay? Change of base formula says this, that log of AB is equal to log of B, so common log of B divided by common log of A, right? And so remember, common log is nice because we can do that on our calculator. So for this one, number 7, since it's 2 times log base 8 of the 5th root of 64, what I'm going to do is I'm going to rewrite that. Okay, so I'm going to rewrite that as, first off, I'm going to keep the 2 on the outside, okay? And then what I'm going to do is I'm going to say, okay, instead of log base 8 of the 5th root of 64, I'm going to write common log of the 5th root of 64 divided by common log of 8. Okay, and so now all of that can be put right into our calculator, right? So I type this into my computer. I start with my 2 times, or my calculator, 2 times, and then I do common log of, now I don't know how to do 5th root of 64 in here, so instead I'm going to do 64 to the power of 1/5 divided by common log of 8. And when I put all of that into my calculator, I end up getting 4/5. Okay, and I would, if I were you, I would strongly suggest you try that one so that you get 4/5 as well. Or I guess it's 0.8, but that's 4/5. Okay, number 8, again, graph the function 2 to the power of x plus 1. So we're going to do that. Okay, 2 to the power of x plus 1. Okay, and you'll notice, ooh, I did that wrong. Okay, in parentheses, x plus 1. That's important because it moves my whole graph up 1, right? That's what the plus 1 does, is it moves the whole graph up 1. So here's our graph. You could, again, use that to your benefit on the quiz. Next one, find the value of log base 4 of 23.9 using change of base. So again, change of base says I can use common log of the top, which is 23.9, divided by common log of 4. And so what it effectively does is gets rid of log base 4. And so when I do that on my calculator, I get log of 23.9 divided by log of 4. And I would end up getting 2.2895, I guess, and I would round it to 4 decimal places. All right, very good. Last problem we talked about was interest problems. Okay, so number 10, it says find the balance of an account at the end of 12 years if $6,500 is invested at an interest rate of 8% compounding continuously. So for continuous problems, we use this one. A equals P e to the RT power. So it's like PERT, I guess is how I remember it, right? So if I was going to do this, okay, I'm going to scroll down for just a sec. If I was going to do this problem, okay, I know my principal. That's the original amount of money that was put in. That's the 6,500 amount. E is just E, right? It's our Euler number. And then to the power of R, well, R is 8%. So I have to write that as a decimal. So that's 0.08. Remember, if you want to get a decimal from a percentage, you divide by 100. So 8 divided by 100 is 8 hundredths, or 0.08, times the number of years, which is 12. And so I can just put this in my calculator. And when I do that, 6,500 e to the power of 0.08 times 12, I end up getting 16,976.03 because we round to the nearest penny. Okay. The other important equation for finding interest is our interest rate equation, which was this. So I'm actually going to get rid of this real quick. This one was A is equal to P times the quantity 1 plus R over N to the NT power. And so that's important because N is the number of times it's compounded in a year. So for example, if they said quarterly, your N would be 4, okay? Or if it was monthly, your N would be 12 or whatever, okay? So this is another important one that you're gonna wanna know for your quiz. All right, hopefully this was, I know it was kind of a quick review, but hopefully this was kind of helpful. I would highly suggest you go through these problems again, try and figure some out. If you want to look some up to find similar ones, that would be a great idea. Good luck on your quiz.